Okay. So, okay, you should see my screen now. So here's the thing. So Unix is like the old grandpappy of all of these core operating systems. Okay. And Unix actually comes, I believe, from another version of the old digital equipment, DEC, the DEC system. Now, the thing with Unix is there are so many flavors, and I'll try and find a chart that has the entire tree of operating systems, where they came from, because they took things from different areas. So, like, you'll hear other operating systems. Do you either of you guys heard of or remember an operating system called OS2 from IBM?
No.
Okay,
No.
so OS2 was a phenomenal operating system that IBM developed, but in true IBM form, they couldn't do anything with it, and Microsoft beat the pants off them. Microsoft has had the uncanny capability of developing a very, very poor operating system and getting everybody to believe it's great because it's easy to use. Mac is a very easy operating system to use, and yet they had a very difficult time at the beginning getting people to use it. So one of the things that happened on the Unix side is it split out, and this guy called Talvarius Lindus or something like that created something called Linux, and it's named after him. He is the father of Linux and all the flavors. So the flavors of Linux include Red Hat, Ubuntu, SUSE. There's like 2 or 3 others I can't remember off the top of my head. They're all basically the same. If you ask me the difference, honestly, I couldn't tell you. The one thing I know is that the front end interface, some of them have the IDEs, like a Windows environment. Those are definitely different. But the other differences I would not know. Does that help?
Yep. Now I understand.
So Mac is actually a derivative. The core operating system underneath it is what's called BSD, Berkeley Software Development. That is actually a Unix system. So it's actually not a true Linux branch, which is why some of the things that we try in Linux don't work on the Mac.
Okay.
And y'all, I mean, I hate to say it this way, but you kind of figure it out. They're very close. I couldn't tell you which ones were different. I just know they are. And I'm like, I'll go look up something and then it won't work. And I'm like, oh, you suck. And then I got to go find out which one it is, so. But that's just it. Folks who deal with this as system admins all the time, they could recite like memory addresses as to why they're different. So That's not me. Does that help?
Yep, got it.
Okay. But if you're communicating, like Vanessa, you still have the Amazon server, or you have the other server?
Yeah, I have the Amazon.
Yeah.
I haven't been on it, but yeah.
Connecting one to the other is super simple through terminal, and then doing things is pretty much the same. It's really not too much of an issue. The one thing I will say is that you and Vanessa, you're in my class coming up, right? I think.
Yep.
Okay. You're going to want to try as much as you can, and I'll give you a hand as you're going through it. You're going to want to do as much as you can in the command line. Okay. So you can develop your code in like Visual Studio and have it run, but then occasionally just run it from a command line and output the results to either a database or to a file that you'll view later.
Okay.
Okay. So what happens is you get used to not relying on the development environment for giving you the information. Does that make sense?
Yep.
And it's a total pain. It's really a pain, but that's what you kind of need to do.
Okay, I got it.
All right. Okay, so last time we went through some basic commands of changing the directories, of creating files, moving files, copying files, renaming files. We did some basic other things. We looked at how to find our system and so forth. You guys have any questions on that at all?
No.
All right, so we're going to go through a couple of other things. I got some notes that I'm going to pull up. We're going to do, and I'll put these up on the Slack for us to use. So one thing I'm going to try and do is let's say we want to find a file, right? So this is my set of lists, or my items, and let's say I didn't know that this Instagram existed, but I want to find a file on my system. So hopefully this works. I know this works in Linux, but find in my current directory name, then I want to look for Instagram.py. I love when things just don't work the way they're supposed to. I really do. Hold on. Let's see what happens when it comes back. This is going through a lot of my, there it goes. It actually found it, okay? It actually found it in the current directory that I'm in, which is what I wanted it to do. There are some, what happens is that in this directory that I'm in, there are other subdirectories like pictures, libraries, that running the command I don't have access to. The reason is because my user ID is not running as the super user. It's running as just a regular user, and it's cut off from my terminal account directly, okay? That's why it's important to understand when you're using a user account. Now, did we talk about sudo last time or no?
I don't remember.
Okay, so this is a super user directive. So basically, I want to run, if I do sudo in front of any command, it will try and run it as the super user. So I'm going to try and do the same command. It'll ask me for the password. What the hell's my password? There we go. So it still doesn't give me access to those directories, but it's running it as it is running it as a super user. So there's certain commands that I can do the super user as. There's other commands that I literally have to log in as root in order to do it. On your Linux system, you won't have this much of a problem. On the Mac, certain things are cut off, so it's a little bit more difficult. That's why I'm going to, for next week, I'm actually going to have Hofstra give me a Linux box that I can actually play around with and do some of these things for you. But this is how you can find something within the current directory, and you can find something within any directory as long as you have permissions to do it. Does that make sense? Okay. All right. Now we'll go back to my list. I'm not going to do that one today. I'm going to do this one. Let's have a little bit of fun, shall we? All right. I'm going to output this code. Instagram.py. This is a Python code. Here's the code. Okay? So this is a piece of Python code. Now, let's say I want to find something in that file. I could do it. The way I can do it is by using a command called grep. Now, let's see if I can do this correctly. I'm going to look for the word error inside of that file. Boom, and it found it. See that? It actually found that in that particular file. So I'm going to look for another one. I'm going to look for JSON. And there it finds, it returns the line that that has the search string that I'm looking for. Does that make sense?
Yeah, I have a quick question.
Go for it.
Grep, what language does that belong to? Because I know I've used, like, I think it's grep-l in R before to look for a certain string of code.
Yeah.
Is that Linux, or is that R, or is that just used across?
Okay. It is a core Unix command. It has been around since the 70s, I believe. I can actually check for you. Hold on one second. Man, if I do...
I'm just curious.
Yep, hold on. This has been around for a very long time. Okay, it's one of the core. It's definitely one of the core items, and I know this because of this number here has meaning not based on year, but based on where it is in the operating system. It's a very base level item, but it has been around for a very, very long time. I'm not sure I understand your question, but it's written in C++. Now, if you're talking about, like you said in R, you use the grep command. That's a function, though, right? That's not a command.
Yep.
So what they did was they built a function, called it grep, because people know how to use grep.
Okay.
Does that make sense?
Okay. Yeah, I've just seen it in a lot of places. I was just wondering.
That's pretty much what they do.
Okay.
Okay. So before I get back to grep, and there's a reason for that, is I'm going to show you something else. Let's assume I want to look at the messages that occur. Oh, are you kidding me? Hold on. Cool. See this cool stuff? By the way, I'm such a geek with this Linux stuff because I see all this and I love this. This to me is like awesome. When your computer boots up, these are there are messages that actually the operating system puts into a log file, right? So here I have a log file that basically says, oh, census idle policy timeout, host device suspending pipes, boom, and it gives me a whole bunch of stuff. And there are various log files throughout a Unix operating system, throughout any operating system. But your biggest problem becomes, how the hell do I read this? Now, if I gave you this file, what would you do? If you were looking for something in particular, what would you do with the file? Not in Linux.
No idea.
If you had the file and you were looking for something, right, you would open that file up in something like Word or TextPad, right?
Oh, and then use Control Find. Or
right, and then use Control Find. Right, exactly. Okay. So now what I might do is I would love to be able to find something, right? But the problem is that I don't know how to actually take this, from the dmessage command, that's a command that I run, and actually grep it. Well, we have this capability called a pipe. And what pipe will do is, let's say I'm going to do something like this. Let's try USB. This should, unfortunately, everything I think is, yeah. So I don't want to, let me try something a little different. Let's do purple. Okay. Let's say I want to find everything that has 500 milliseconds in my from that output. Okay. I can run that, and it went to the dmessage and found every line that had 500 milliseconds in it, so that I could see it. Does that make sense?
So it's like a Control F.
Yeah, but what's interesting is that what I did was, do you see the pipe command that I have here?
Yep.
It takes the output of the thing on the left and puts it into the command on the right.
Okay.
Okay? The -I in the grep says ignore cases. That's all I did, because I wasn't sure what the cases were. All right? Does that make sense, Vanessa?
Yep, I got it.
All right. And the reason that's important is because if you are working only in a terminal, right? In a terminal environment, like a server environment where you do not have the ability to bring it into a text editor, what you would have to do is you'd have to download that file from that server, bring it over to your computer, and then open it up to find what you want. And that's a lot. What if the log file is huge? Right? If the log file is huge, you're not going to be able to do that. You'll do it, but it's going to take a lot of bandwidth, and maybe it takes too much time. What if you have a 20 megabyte, 30 megabyte, 50 megabyte, 100 megabyte log file? But if you do something like this, you can actually do grep, and it will go find it for you within that file, and it will do it efficiently too.
Oh, okay.
And that's one of the key things, is it will do it efficiently, which is really what you want.
So I have a question. That -I, what is that saying?
That's case insensitive. Ignore case. Ignore.
Okay.
Okay? Now, what you can also do is we could do different things with regards to grep, but I can also go back to the find. Let's say I want to find in my home directory. am I going to look for? I will do find in the tilde. I think it's dash. I hope that works. Let's do tilde slash dot. I think this will work.
So all things that are greater than that size.
Correct. And again, I'm getting the non-permission, but some of them like these, see, okay, this is pretty clear. In my downloads directory, right? Those files are larger than 10 meg. And this is a way I can actually search my environment for very large files. And these should look familiar, these load salaries.
Huh.
They were pretty big, weren't they? Okay.
That's interesting. Yeah, yeah, yeah.
All right, so that's one of the key things that's important. Now, the other thing I don't think we went through last time, but I do want to do that here, is I want to give you another command on the file system, which is df. I want to do df. Well, let me just clear this. I want to do df-h because I do this all the time. I need to take a look at see how much space I have, what my capacity used is, and what I have available. So here you can see on my drives. Now, the thing that you have to know, right, and I don't think we're going to do this in these Linux sessions because we're not, you know what, I'll try and do mounting a drive next week. Can I do mounting a drive? If I get the new box, I'll see if I can mount the drive. I'm not sure I'm going to be able to do it. I don't have full admin access to do something. But if you get a new drive in Unix, it is actually very different than Windows. You plug in Windows, Windows finds it, then it'll ask you to partition. A lot of that is the same. There's a function called, which I cannot run because I don't want to partition my drive, called fdisk, which is basically to create partitions on your drive, okay? But whereas in Windows, you have the C drive and D drive and so forth, those are called your mount points. So Windows did a wonderful thing, I can't believe I'm saying that, where they labeled with letters the drives, A, B, C, D. You know what A and B are, right?
Nope.
You don't know A and B?
A is external, right? Like
Yeah.
for the what was it, like the floppies or whatever.
Yeah, that's it. Look at that. Yeah, it was the 5 1/4 floppies were the A drive. Your B drive was a secondary floppy, which was a 3.5-inch drive with the hard floppy disks, little cases. And then the C drive was set as the boot drive.
Wait, what's a floppy disk?
Go away. just go away. Okay, I don't want to hear it. Okay?
What's an antenna?
Yeah, exactly. What's radio? Oh God. You mean like you didn't stream television shows? Way to go, Chris. I appreciate that, by the way. So what you have are called file systems and mount points, okay? So this is your file system here, this dev disk at 1 S1. This is actually device disk 1. I forgot what S1 stands for. I don't think, it's not sector. It might be segment 1 or something else. I just don't remember what the S is. In this case, this is disk 1 S4, right? So it's another area of the drive. And what happens is that these are mounted as root, root dev, root private. So if you go to the root drive, right, like in your C drive, it would be like C:\\. In Linux, I could go to root and I could go to any other mount point I want, regardless of the drive that it's on. It's all in the same hierarchy of this root, the slash. Everything extends off of that, even though it's different mount points. The different mount points actually are nothing more than directories. So it looks like it's one giant system. Does that make sense?
Yes.
And it's a pain sometimes to mount drives, but when you get it, it's actually very cool. We did that with the Raspberry Pis, and you can, when you put in a USB stick, it will actually mount. I don't have one handy, but you know, you would, if I put it in, Mac automatically mounts it, but on Linux, it may not do that automatically. Okay? You may have to do that and give it a mount point. another similar command on the disk usage is going to be, actually, I could run, let's try this. I'm going to try this. Hopefully it doesn't, if I get this wrong, I'm dead. List. Okay, I don't know the command. On Linux, you can do -L, and it will list out the partitions. I'm not initializing. I'm not updating. I'm not auto-partitioning. I'm not doing any of those things. Okay, I'm not touching fdisk. Not here, at least. All right, so the other one is, let's do this one for DU. This is basically going to tell me the disk usage of all my files and the directories in a nice, easy format for me to read. Whoops, Control-C, because I'm going to end that. So you can see it gives me each file, and it tells me how big it is. So you might do this in a subdirectory. You might do this for a particular file, and so forth. But you don't necessarily need to do like DU on the root directory. If you do DU-SH, it tells me it's going to go through the folders and tell me which folders have what space allocated to it on my drive, which will be 60 gig. Okay? 60 gig from the current directory that I'm in, which is a lot, which I don't really care for. Be everything. Okay? All right. Now what I'm going to do is I'm going to show you how to run applications like an R application from the command line. So let me find one, which I have on the desktop. Give me 1 second so I can find the one I want to use. And you'll notice that I just go onto my Mac to find stuff because it's just so much easier. I can't do that one. Let's try downloads. Come on. Okay, here we go. So let's do, which one do I want to run? PC functions, k-nearest neighbor. Guess I can do this one. Where are you located? You're at Google Drive. That's nice. So let me copy this, because I think this will run, and we'll paste it here on the desktop. Okay. So I'm going to go to my desktop. Okay. And okay, there I've got my R. I'm going to run this k-nearest neighbor. So if I want to run this, I'm going to type R script. Now, if you're running Python code, right, you would do Python or Python 3. So it would look like this. You might run Python, or you might run Python 3, okay, if you're running Python. For R, you're going to do R script. And we're going to do k-nearest.r. When I run this, hopefully it will run. It needs a file, of course. Okay. Let me just do a small little file really quick.
So you're basically looking for whatever file you were doing in R, where you were doing a k-nearest analysis.
That's correct. So what I'm going to do is I'm going to do x1 through c 1 through 10. I'm just going to write a quick one. Y equals r norm 10, 0, 1. And then we will do model equals lm y by x. And then we can do MDL. If I save this, just run the whole thing to make sure it works. And it does. I will do summary of MDL. And that'll give me everything that I need. Right? All right, cool. File, save as. We'll save this onto the desktop. Linux R script.r. Cool. All right. So now if I do ls*.r, there's my Linux R script. So now I'm going to run it. So I'm going to do R script. I'm going to clear this out. R script Linux. What do I call it? R script.r. Boom, and it ran.
Oh.
Literally just ran the code and gave me the output. Okay? Take a look at what it looks like, just so that you have an idea. is important. This is my code. Okay. X, Y, model, summary of the model. Okay.
Mm-hmm.
Now, the output, the standard output from the script is what you saw on the screen. Does that make sense?
Yep.
Mm-hmm.
Now, that doesn't help generally if you decide, you know what, I need to see it for later, or I need to use it for later. So what I will do, and I love, is this. I'm going to clear this out. I'm going to run the script again. The only difference is I'm going to send the output in the same directory to a linux.txt file because I want to save the output. So the output will now go to linux.txt. I run it. Shit, didn't do anything. Didn't seem to do anything, right? So I'm gonna let me do ls linux star. Oops, where'd you go?
You just list what's in it.
Oh, here it is. Linux.txt. I did it lowercase. That's why. So now I'm going to do a cat linux.txt.
Mm-hmm.
Wait a minute. That wasn't my output. Let's do that again. Hold on. Oh, did the wrong thing. Sorry about that. I wanted to actually run the code. Cat, remember cat displays the file?
Mm-hmm.
Okay, so what I had done was I did cat linuxscript.r, and it took the output of that, which was the file, and it put it in linux.txt. That's not what I want. So I want to run the script. Now that I've got that, now I should be able to cat linux.txt, and there's my output. Okay? Does that make sense?
So what is the benefit of doing it here versus just doing it in R?
Okay, so let's say you have a process that takes 30 hours to run, or an hour, 2 hours to run, right? Or you have a server that's running on Amazon. Did you do the Amazon server, Chris?
No, I haven't. I'm still looking it over.
Okay, if you didn't install RStudio as a web service, where you could go onto the server with the web browser, right, and connect to it. Did you do that, Vanessa?
Yep, I did.
Yeah. Okay. Now, when you do that, you're taking up resources. Okay. So if your web browser has to listen for requests, it has to display graphics and so forth, and it takes up resources. You may not want that wasted resources. You may just want it to churn like an engine. Nothing else. No frills. So if you're going to do that, you write your R code and you run it from a command line, and now you have no other processes that are taking up memory or taking up processing power. Does that make sense, Chris?
I'm still a little confused.
Okay. You connect to your Amazon server, correct?
Yes.
And let's say you know that handwriting recognition thing that we did in class?
Yes. Yes.
How long did it take you?
One effort took me almost 3 days.
Okay. So it takes a while to run that code, right?
Yeah.
Now, on your computer, you have other things running. Netflix, Fortnite, right? All that stuff, right?
Yeah.
Okay. All of that takes up processing time and power from your computer from running this, right?
Mm-hmm.
But what if you had a computer that had it's called headless. It has no display. All it is command lines. There's no extra processing power going to input-output.
Okay.
I can run my code like this, have it run, and then output the results where I need. And then I can view them later. Does that make sense?
Yes.
Okay. So by doing it this way, I am ensuring that the program is going to just run in perpetuity. Okay. It can just run without any problem whatsoever. Okay.
So if you have your command lined up and you run it this way and you've still got other programs open on your computer, this ignores the other? How does that work?
So if there's things running on the computer, right, it all takes up processing time.
Yes.
Okay. So that there's no way around that. But if you have a Linux box, right, or a server where you don't need anything but have it do R code,
Gotcha. Gotcha.
That's all you need. Now, what I'm
Gotcha.
going to do is I'm going to alter the code slightly. Okay, I'm going to alter the code, and I'm going to put something called the sleep command. And I want it to, I think sleep, just give me 1 second. Sleep.
Hey.
Time in seconds. Okay, cool. So what I'm going to do is I'm going to put a sleep time in seconds. So we're going to
I
say,
do this on my web crawler so they don't ban me.
yep. I'm going to run this. Okay, I'm going to run the program again, but I'm going to run it straightforward. I just modified the code so that it would sleep for 10 seconds. So I'm going to run it. 1, 1,000, 2, 1,000, 3, 1,000, 4, 1,000, 5, 1,000, 6, 1,000, 7, 8, 9, 10. Close enough. There we go. Okay? Does that make sense? So this program takes 10 seconds to run. Now, even if I were to output this to this file,
It'll still take 10 seconds.
still takes 10 seconds to run. Right? I'm going to let it run. Now, here's the cool part. Okay. Now, first thing, before I do anything, I actually want to, if I look at the Linux file, this cat Linux, clear, what did it do? It outputs to that file, right?
Mm-hmm.
So what if I had subsequent runs? I would like to be able to append to the file. Well, you can append to the file by changing this from a single greater than sign to a double greater than sign. So I will run it again. And you'll see that both runs are now in that file. That make sense?
Yeah.
Okay, and that's good when you have multiple runs and you want to keep track or history of everything that's going on. But that still doesn't solve my problem of, it's holding on to this terminal for 10 seconds. But I can fix that. Because if I now run this with an ampersand at the end, right?
Mm-hmm.
What just happened? Came back, right?
Something did.
Well, this is the process that it created, okay? And it came back, so I can kind of just continue working, and as soon as it's done, it actually sends a message saying it's done. Okay?
Mm-hmm.
Which is interesting because now if I look at the file, where is the file? Oh, sorry. I got to go back to my desktop because I changed the desktop. Here's the third one. You see that?
Yep.
Yep.
So that's very cool. Now, what I'm going to do is I'm going to alter this again to be 20 seconds. The reason is because we're going to run it one more time. I'm going to run this again with the ampersand. Okay. And notice the PID there. That's the process ID, 42214. I'm going to run this, top, 42214. Look at that right there. It's running. See that?
Mm-hmm.
And it's in a sleep mode right now. So it's really not taking any processing time. The computer knows that it's in sleep mode, so it just holds it there. And then in about 20 seconds, bye-bye, it's gone. You see that?
Yep.
And this is where you get really the power of doing this stuff, is you're making sure that I can still do whatever I want to do while that process is running. Okay?
Mm-hmm.
And ultimately, you know how you had those long, the R processes that with the handwriting recognition?
Yep.
Yep.
Well, you could literally run it. It sits in the background and you continue working. Now your R Studio was working and so forth, and you could still kind of work, but your system was slow. But here you can put it into the background and you have a little bit more processing power. Now, if you really want to what you can also do in some computers is you can do something called a no-hop, right? And what no-hop does is no-hop basically is pretty much the same thing. The only difference is what no-hop does, in some units you have to do it this way, some Linux you have to do it this way, otherwise you don't. It basically ignores what's called the hang-up signal, okay? And it's a way terminal warns processes of logout. All right, so here's what this means. Let's say I run like this, right? I run this command, it's running. And now I log out, okay? Which, let's assume you did a log out. That process is over, okay? That process stopped. You're done, okay? Does that make sense? So,
Yep.
oh, hold on. But what happens if, I'm sorry, I gotta bring back up my terminal. Okay, so can you see my terminal? No, you can't. Now you can, right? So now, what happens if you want to just, you have a Linux server on Amazon and you want to run the process and you don't want to leave your computer connected to it, right?
Right.
So we do no-hop, which means ignore any hang-up process. Basically what this will do is if you're on your server and you run it this way, it will run in the background. And if you log out, it will continue running until it's done.
But it's still connected to the server, though.
The process is running on the server, but you can disconnect from the server and it will still run.
Okay.
And that's cool. Because remember, you guys were running that handwriting recognition and it would take hours, right?
Yes.
So what you do is you put the code up on your server, you run it from the command line using no-hop, you kick it off,
And let it run.
it runs in the background, and you disconnect and you come back later and it's working. Does that make sense?
Yeah.
And that is the real cool part of this. You can control processes, where they run, how they run, and you're not beholden to them. All you need is that computer to stay on. And Linux is like, okay, I got it. I'll take care of this. You go have coffee. Okay?
Huh.
Now,
Yeah.
Now, the problem with running it that way, though, is you would like to know when it's done, right?
Yeah.
So first, you have to mark you really need to know. Let me just get out of this. So if I run this again, you see the process ID here is 42312. Okay. No user named X. 42. What the hell is it? I might have finished actually. Hold on. Let me do it again. No-hop script. Oh, let me run it this way first. Four, 2, 3, 2, 6. Right? What the hell is it? 4, 2, 3, 3, 6. Hence the problem finding this crap.
Didn't you use grep?
Yeah, you could. You absolutely could. I don't know what the hell.
Oh yeah, you found it down below. It was 42326. I was saying it wrong in the microphone.
You sure?
I think so.
Okay, hold on.
Maybe I'm.
You know what? Let's try and do the grep thing while we're at it. Okay? So I'm going to run this. And by the way, you see how it exited?
Uh-huh.
So I'm going to run it, and then I'm going to do PS AUX pipe grep -I 42330. Finished. Couldn't get it. Oh, let's try this again. 42553.
Forgot the P. Yeah.
And there you go. See that? That's how you use the grep effectively there.
Mhm.
Okay. So now if I run the NoHub, it gives me that process again, 42368, 42. What do you see here? It's
Mhm.
not on here because it's running in the background, right? Because it's
Mhm.
sleeping, and it's a background process, so it's not a top process.
Okay.
Okay.
Don't see it.
Okay.
Right, because it's not going to be here because it's running it's totally in the background. It's orphaned from my login ID, and it's not running, so it doesn't really care. It's
So
totally dead.
you said earlier there was I wrote it down, I think, but there was a command you did to see what was taking up processing power, to see what was running. So if you were to run that now, would you be able to see that it was running in the background?
There's a way to get the background. I don't remember the exact command, but the other problem is that it is asleep, so
Mm-hmm.
it's not going to take up too much processing. But if you've got something that really runs like a lot, like your this would be good to take your handwriting thing and
Mm-hmm.
literally either run it on the server or run it, even just running it on the background on your computer,
Mm-hmm.
you can see what's actually happening. Okay, and this is
I have another.
good.
Yeah, sorry.
No, go ahead.
So for the handwriting thing, that I'm just remembering back, one of the big errors, or one of the things that I had to cancel it out, was when it ran for like 2 days, it would say it runs out of runs out of RAM, or it runs out of memory. If you were to run it in the background, would it still run into that problem?
Yeah, so it would still run into the problem because the memory is the memory, but what you ultimately want to do here is you're going to do something that looks like this: 2 greater than ampersand 1 ampersand. That basically takes the standard error, puts it to the standard output, so that then anything going to that log file will actually, if there's an error, it goes to the log file, not just what you output. Okay? So there's a
Okay.
thing called the standard error and standard output. And there's also standard input. The standard input is your console, right? That's what you're typing stuff in or you put in through a file. Your standard output is things that you print out from your code.
Mm-hmm.
And the standard error would be errors that are not part of the standard output. So let's say it crashes. Let's say R crashes. R can't
Mm-hmm.
send anything to the standard output. But it does, the operating system knows that there's an error and sends it to the standard error. By doing this 2 ampersand, 2 greater than ampersand 1, it will send your standard error to the standard output. Your standard output is already being sent to the linux.txt file, and so therefore you will get all errors as well.
Mm-hmm.
This is where these commands start getting a little bit more complicated. But the key is for you to understand that this can happen. In other words, that you can do these types of things. Because when you start writing real long data science code, Vanessa, are you in the social network analysis class or just the multivariate?
Both.
You're in both. So in social network analysis, some of those processes can take hours. So you run them on a small snippet, you get it to work, and then honestly, you connect to your server at like 10 o'clock at night, 11 o'clock at night, you kick it off, run it as a no-hub process, come back in the morning and see what happened.
Oh.
And you don't have to leave your computer on. And this is exactly what we do all the time. I mean, we've got processes that run for hours. So what will happen is in our office, we have a server, and one of the data scientists will literally just push it to the server, run it in the background, let it run, and then they use their computer for other things. And what we've been good at is like we will write, like in the code, we will write records to a database, right, that's running on the server, so that it's like, hey, we succeeded here, we succeeded here, we succeeded here. So we don't have to log in to go get the log file. We can just query the database and find out where it's at. Does that make sense?
Mm-hmm.
Those are some like more experienced tricks. That has nothing to do with Linux. That has to do with how do you decide to How do you decide to write your code? Okay.
It's efficient.
It's really, really cool. I mean, it's powerful when you can do this. Even some members of my team, when they first start doing this, they're just like, this is amazing. And it's being able to do it at the command line that's important.
And this is through the Amazon R server, right?
You can do it in the Amazon R server. You can do it in that Hofstra Unix server as well. Any Unix server, any Unix box. In fact, and I've told a couple students this, you should set up, I used to say set up in your house, but now I tell them just set up an Amazon server. But you should set up a Unix box, either in Amazon or in your house, so that you could run code and literally just send it to that box and just let it run. And you don't need a keyboard. You don't need a monitor on that box. You should be able to have the box run plugged in somewhere. And all you do is you will connect into that box. Next week, we'll do SSH, and I'll show you how the SSH works. But it's not and we're going to do SSH and SCP for Secure Shell, where you see how I got my terminal here. Well, I could terminal into my Unix box on the Amazon server, or I can copy files back and forth using something called SCP, secure copy.
Okay, I have a question. When you say Unix box, are you talking about a machine, a single computer dedicated to that?
Yeah, your Amazon box. It could be your Amazon server that's running Linux, or it could be a computer in your house. Could be a laptop too, that literally sits and has Linux on it.
Here's a question for you. I have a NAS server, right?
Yep.
So is there a way to install, I guess, Unix on that?
So first of all, NAS servers usually have a Unix subsystem underneath it.
Oh, they do? Okay.
Yeah, I don't know of anyone that doesn't, to be perfectly honest, but that doesn't say it doesn't. But the problem is they're specifically kerneled so that all they do is the network service. They don't do anything else. But what you can do is, if you have do you have an old computer in the house somewhere?
Yeah.
What type of computer is it?
It's a Mac, the other MacBook Air.
Oh, so if it's a MacBook Air, you can, obviously that has Unix on it already. But if you have an old PC somewhere, sitting around doing nothing, you basically format the drive, put Unix on it, like Ubuntu server, not Ubuntu desktop, right? And the thing will fly. Just to give you an example, about 6 years ago, I put on an old computer for my parents, my mother specifically. I put Ubuntu on it. She only had half a gig of memory. And the thing outperformed her Windows computer.
Okay. Wow.
Yeah. Because Linux is so lightweight. All she used it for was shopping. She used it for browsing, right? But what happens is that it is so lightweight that you don't have all these other things that slow you down, and you never get a virus. I'm not going to say it's impossible, but the odds of getting a virus if you're using command line are so remote.
Okay.
Okay.
Let's go.
All right. Any questions on this?
No.
All right.
Not yet.
A lot of fun stuff. We're going to try it this week.
Yeah.
Well, Vanessa's going to try it this week because in the class, you're going to start setting up your server to do all the art. Yep. You're going to use I'm going to talk to Hofstra to get those virtual machines. So if you want to use one of those instead of Amazon, you can do that.
Okay.
Too.
Okay.
I'll let everybody know in class on Tuesday and Thursday, and then what I'll do is I'll suggest the 16 gig of RAM. And if you need more, then we'll get more. But I'm really going to push everybody to do Unix or Linux, because you really have to know. Do you guys understand why I keep talking about the power of this stuff?
Mm-hmm.
I guess Chris doesn't.
Yes, I do.
Oh, you didn't say yes. You just kind of like nodded. All right. Any other questions?
Nope, I'm good. Wow.
All right, then I'll see you guys next week. But I'll see you Tuesday, Vanessa.
Okay. Okay. Thank you. Good
you.
night.
Bye. Later, Chris.
Later. I have a quick question for you.
Sure.
On a scale from 1 to definitely don't do that, how much trouble would I get if I were to suddenly appear on Tuesday?
I'm sorry. Who are you?
Okay, perfect. Thank you.
I have no idea what you're talking about. What are we talking about?
That's perfect. All right. Thank you.
Which class is that, by the way? Wait. Hold on.
Well, then I'll see you next week